Welcome to Automated Visual Software Analytics. This part is about the nesting level metric. In this part we will define the nesting level metric and we will discuss examples and their properties. Let's start with the definition. The nesting level metric is a software metric that quantitatively measures source code complexity based on how deeply control structures are nested. In programming, nesting is applied in many forms, including in the form of nested levels of parentheses, for example in arithmetic expressions, in form of nested blocks of source code, for example if you use if clauses, while clauses or repeat until clauses, and in form of nested namespaces or nested classes or nested methods. Nesting level in general denotes the level of containment, the depth of a logical source code block in its scope, typically also a source code block. The nesting level metric can be computed by static source code analysis. There are some variations of this software metric. These variations include NL, the standard nesting level metric, the highest nesting level of a given source code unit. There's also a variation called loop NL, the highest nesting level of loops in a given source code unit. So it focuses on this specific programming construct, the loops. The mean nesting level, that means the mean nesting level of multiple source code units, for example, in a whole class or module. And the nesting level above a certain value, starting at typically 2, 3, 4, or 5. And it's denoted NL4 plus or NL5 plus. These are some variations of this software metric. Let's see some examples. In the first example, we have a nesting level of 0 because in these 9 lines of source code there is no nesting at all. There appears to be a nesting here, but this is just a formatting issue. In the next example, we have a nesting level of 1 because there is a source code block. In this method definition, the function or the method is implemented in this block and therefore the nesting level is increased. Therefore we say, well, this method implementation has a nesting level of 1. In the next example, there is an if clause which increases the nesting level, so the maximum nesting level of this source code unit is 2. In the next example, we do find 2 for loops, and they are one after another, so the nesting level is still 2. However, in the next example, when the loops are nested, when the for loops are nested, of course the nesting level increases, and here we get a maximum nesting level of 4. What about the properties? High nesting level values for source code unit generally indicate that more effort has to be spent on program understanding and comprehension. Especially in software maintenance, this is typically a big issue. The underlying observation is that deeply nested code becomes extremely difficult to understand from a cognitive point of view. So it's just difficult to read such implementations. The nesting level metric measurements can be used to identify those parts of the source code that should be redesigned or refactored using different concepts such as modularization, abstraction, or encapsulation strategies. Nesting level measures beyond a certain threshold identify those source code units or parts that are likely to be difficult to understand, to fix, or to maintain. However, the threshold depends on your project, but common values for thresholds are 4 or 5. Now, let's see how, based on such an observation, a source code might be changed. In the example on the left side, you see the original source code having a nesting level of 3. And this results because in this if clause there's another loop contained. And one way to resolve this high nesting level is to change the control flow or the way the control flow is programmed. For example, if we have an early exit here, the nesting level in total is reduced by 1, so we get a maximum nesting level of 2, just because we have changed the way we implemented the control flow. So sometimes a deep nesting, high nesting level or deep containment can be changed if we change the way we implement our algorithm or our technique in the source code. Now, let's summarize the findings of this part. The nesting level metric represents base measurements of source code complexity. It is a simple and easy to compute and even fast to compute source code metric that quantifies the depth of the logical nesting of source code in a source code unit. It is computed based on a static analysis of the source code. So basically we have to parse the source code files. We also observed that a high nesting level for a source code unit generally indicates that more effort has to be spent on program understanding and comprehension. For that reason, nesting level metrics can be used to identify those parts of the source code that should be redesigned or refactored using different concepts, modularization, abstraction, or encapsulation. In particular, this is important for software maintenance, for the long-term evolution of a software system. And this is where software analytics comes in. Software analytics uses the nesting level metrics as base measures for source code complexity in order to have a weight that allows better evaluation, interpretation, or benchmarking of other key performance indicators and software metrics. So in software analytics, we use the nesting level metric as a base measurement that is useful as a weight factor for other metrics. So it's useful and even required. Of course, we have the choice of different source code complexity metrics, but nesting level is an important one. We have the choice of different software metrics, but in any case, the nesting level metrics serves to estimate the source code complexity. This is why software analytics is interested in this software metric. Now, this concludes this part about the nesting level metric. Let's see what terminology has been introduced. It was one software metric, the nesting level, as a quantitative software metric, measuring the depth of the logical nesting of source code that reflects one aspect of source code complexity. It is computed by static source code analysis. As further reading, I can recommend, for example, this blog, Stack Overflow. There's an interesting discussion on how many nested code blocks do you end up with in practice when coding. Have a look at it. Let me end with some remarks. The nesting level metric is an easy to compute and effective measure of source code complexity. For example, it helps to identify source code units that may deserve redesign. Nesting level metrics also help to identify those parts of the system that show an uncommonly high algorithmic complexity, as indicated by high nesting level values. If this is the case, check whether you have good reasons for deep nesting levels, and you should carefully check them and discuss them. Always consider the long-term maintenance costs for high nesting level source code parts.